Hey everybody, this is Larry. This is me going for Q4 of the weekly contest 399, maximum sum of subsequence with non-adjacent elements. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So if you click on this and you're like, wow, this video is 3 hours long, or whatever it is, don't worry, the explanation will be much shorter, though it might not be that helpful, to be honest, because this is a hard problem. But what I did was that I upsolved this during, I couldn't solve, I wasn't able to solve this during the contest, so I upsolved it afterwards, and you get to see all of that live. And you know, one of the things that I always talk about is just grinding a problem out, and you get to see a lot of that grind slowly and eventually, including some stuff about the contest servers being an issue near the end. So definitely check that out if you want. But you know, I spent many hours on it, and I was very happy with what I got. But yeah, one thing that I wanted to address is that apparently the constraints are a little bit too silly for Java. So a lot of people solved it in Java using I don't know if this is using basically the brute force way, the n square way, or n times q way, I guess more specifically, which apparently in Java is somehow fast enough. Good job, Java. But in any case, so there's 1,000 people accepted, none of them me. So this is probably this is actually like my worst contest in a while. But that's not even the point. The point is learning, and that's fine. My only complaint about this problem also is that we had 2 segment tree problems in a row, and yes, this is a segment tree problem, or the intended solution, I believe, is segment tree. Gia or just Gia on my server said that this is a textbook problem, and I don't know. I didn't have the textbook, so you know, I would also say, and I'm as someone who actually knows segment tree, but not like a good level, but not super in depth, like maybe superficial, black boxy, like I know segment tree maybe one level more than black box, but not that deep, right? So I think in that sense, I learned a lot. I learned how to use it in a cool way. And I feel like in that way, it forced me to learn this, and it was kind of cool. On the other hand, as I say, I said it in the other video earlier today, right? Unless you're like really, really, really good, and I'm not trying to say that about myself, this is not a humble brag, you can probably improve on non-segment tree problems, right? Like you could be better on binary search, you could be better on ternary search. There are a lot of things you could be better on. So if you're studying for an interview, definitely learn other things better. Segment tree is probably not going to come up. I mean, maybe it does, but probably not. Most likely not, right? Your interviewer probably doesn't know what a segment tree is, so you should be fine. And as I said in the morning, or in the bi-weekly contest problem, unless you happen to be Indian and your online assessments are ridiculous. But nonetheless, even for a segment, I would also say that even for a segment tree problem, this is a little bit on the harder side. During the contest, I did think about trying to use segment tree in some way for this problem, and I didn't know how to do it. So I would say that if you haven't seen this style, like I don't want to call it a pattern, but this style of usage of segment tree before, then you might not be able to come up with it. I did actually come up with an alternate solution that is still a little bit too slow, though I got it to AC. I got it to get accepted. And maybe that'll be the better way of explaining it first. So I'm going to explain it the other way first. It's a little bit too slow. But I think it's a cool concept, so we'll go over that. And then we'll go over time back together, how it relates to segment tree, and I don't know if this is the best way to teach it, to be honest, but the way that because I knew, or I thought maybe it was segment tree, but I couldn't figure it out during the contest, and then I tried this other method, and I was very close, and I eventually got it, but it took a while, and through that exploration, I was able to go back to the segment tree and be like, oh, now I understand how everything fits together. Now I can use the segment trees on, and I did it very quickly, maybe a couple of minutes. You could watch it in the live portion. When I actually switched to the segment tree implementation, it was very fast, right? Or like I implemented very quickly is what I mean. So okay, so the idea that I'm going to bring up is going to be square root decomposition. And this is actually, I mean, again, I just want to make this clear. Segment tree is not going to be on your interview, right? Probably. Please don't hold me to it. But I'd rather be better on other stuff on an interview than segment tree, because it just like probabilistic never comes up. At least as of this recording in 2024. I would say I'm surrounded by a lot of really smart colleagues whom are good at, or they've been in software for years and years or whatever, really good and competent. None of them has heard of segment tree, probably, right? Maybe the younger people, I don't know. So, I don't know. I cannot stress that enough. But also by the same token, why do I have this thing up? I don't want to show that. My rating is terrible. By the same token, the square root decomposition is also not going to be in this. But I wanted to show you how I think about this, right? So what is and this? I mean, this is going to be a very quick intro. I do recommend people Google up square root decomposition and kind of get a better idea. This is just going to be like very, not super hand wavy because I have code, but just like a general idea. And I think with the general idea, you can start everything from scratch. And that's how I did it. That's why it took so long, is because I did have to like figure out every step of the way by myself, right? Like I didn't have, like maybe I have some minor prior experience in guessing, but I haven't done square root decomposition in a long time. And definitely, yeah, there's some stuff here that, you know, but yeah, basically what is square root decomposition, right? The idea here is that, okay, you have an array of size n, right? Right? So the idea here is splitting up into chunks. So let's say you have P for parts, and each one of these is size S, right? For length, I guess. No, let's just call it L. What am I doing? So then obviously P times L is equal to N, assuming that there's no leftovers, but let's say that for now, right? So then now, what do we want to do? So the idea here is that, let's say we have P parts, each of these is of size length, or L, right? So then now, the idea is try to figure out a way such that we solve it for all the L's and then combine them together, right? And what does that mean? That means that, okay, let's say we have an algorithm for L, for the small pieces, and in this case we do. I don't want to go over, I think this part I actually kind of skipped ahead because I think for now, like if you don't understand the dynamic programming solution, I should have brought it up earlier though. If you don't understand the dynamic programming solution, you're probably very far from this problem. And I'm not saying this to be mean, hopefully not. But there's a problem on Leetcode called house robbers or something like this. So definitely work on that and really understanding that part of it. Because that's just, I think now it's probably like a medium problem, maybe even a easier medium. So you definitely need to know that. I'm definitely not spending time there because this video is already going to be long enough. My explanation is going to be long enough, right? Okay. So then now, so then we use that dynamic programming solution on the L piece, right? So then now you have O of L, right? And because there are P of these, we have to do P times, so it's P times O of L. So this is going to be O of P times L, which is going to be O of N, right? I don't know why it was so weird. Okay, so I mean, yeah, but that just, and then now, what this means? This means that we have P answers because we have P different pieces. We have P answers, and then the idea here is that we can connect these pieces together, right? If we are able to connect these pieces together, then we can do a for loop to get the answer. And of course, if you only need to do this once, this is going to be O of P times L plus P, right? So this is going to be O of N, roughly. But what if you need to do it Q times? And you just do, let's say there are no updates, then what happens? then, well, this is going to be over P times L plus Q times P, right? For whatever reason. Maybe you have to connect only a couple of pieces or whatever, right? Like maybe you only need to connect a subset of these. I don't know, right? Technically N plus Q, I think, right? So then the idea with square root decomposition is that for this particular problem, each query, what happens when you change something? Well, when you change something, let's say we change an index that's inside here, right? Well, that means that we have to recalculate all this. But because we're already doing a for loop on every query, after we recalculated this shaded area, this is still going to be O of P times L plus Q times P times L, right? And of course, this is now going to be N times, or N plus, if we do it this way, it's going to, oh, wait. No, this is wrong. I wrote it wrong. This is why. It's N plus P times L, because you do one P loop and you do one L loop, right? So then now this is N plus Q times, let me rewrite this. Whatever. Let's just say now we have this, right? Oops. As the complexity. So then now we have to choose P and L. How do we minimize P? Now given this function and this complexity, how do we minimize the overall complexity? Well, it turns out that now you have to minimize. So the Q you can take out because it doesn't change the result, and the N is on the other side. So you're basically trying to minimize P plus L such that this condition is true, right? P times L is equal to N, and of course the idea and if you draw the curve of P times L and P plus L, whatever, then P is going to be equal to square root of N, and L is also going to be square root of N, and that's your answer. And then the idea here is just what I said, which is that every time you get an update, you update this chunk, and then you do a loop through the entire P chunks. So now this solution is going to be O of N plus Q square root of N, right? And that's basically the idea of square root decomposition. Hopefully this makes sense, but this is not the entire problem, right? So this is just an idea about general square root decomposition. The tricky part now is to figure out how to use, let me actually bring this back, how to use it for this problem, right? Again, I'm going to reiterate that we're not going to go over the house robber problem of the non-adjacent element subarray thing, right? So I'm not going to go over that. The idea here is that, okay, let's say you have n chunks. So how the hardest part is how do you, I hand waved going just like doing a for loop after we do an update, right? But then now, how do you connect these two pieces together? Well, the idea here is that, okay, in this particular chunk, there are really 4 possible combinations of answer, right? Maybe I'll use the middle chunk because it's more iterative. There's basically one answer that does not use, one answer that uses the entire chunk, right? So this is answer 1. The second answer is it does not use the beginning, right? So XO, or this is an X. The third possible thing is the answer not using the N. And then the fourth possible thing is not using the beginning or the end. Why? Why is this sufficient, right? So this is sufficient because because for this problem, you're just trying to not figure out, or you're trying to figure out how to combine them. And you combine pieces as long as they don't have consecutive sub elements, right? Subsequences. Sorry. So that means that, for example, if you have for example, you cannot use pieces 1 or pieces 1 together, because if you place 2 of them next to each other, that implies that we are using the first element and the last element. But 1 plus 2 is okay, because now you have a whole first element, and then the second element you don't use it, so you guarantee that this will give you a possible answer. And then you can kind of play around that idea, right? So like 3 plus 4 is also okay, right? Because now this is an x, and then this is an x, this is an x, and you kind of extend this infinity, plus 1, for example, and keep on going on, right? So that's basically the idea, is that now you're able to kind of combine them and loop them in this way, and you just have to keep track of 4 possible answers to the house robber problem. And now with all that, it's hard, I know, hope you're following. And with all of that, I think, is it this one? Yeah. We'll go over the code, right? So here, I have m pieces of, or p pieces of size m each. I keep track of the mod that you asked to. The answer, so this contains 4 pieces, which is what I have here. Yeah, I mean, we'll ignore this for now. And basically, for each I, for each piece, we calculate this. And here, my naming is hopefully a little bit good. It's just basically use left, no right, use left, use right, use no left, no right. So it's skipping left and skipping right, and then skipping left and using the right is okay. And I calculate these two together because skipping the last element is just equal to the answer to the second one on the house robber problem. And this part is just the house robber problem, except for that I just kind of use the indexes, and this is very standard house robbing stuff. Man, I gotta stop saying that. Saying that is kind of awkward. But this is very standard dynamic program for that solution. I'm going to type it on screen so you could Google it. I forget what the Leetcode number is, right? But yeah, but this is basically that, except for I return the last value, which is the maximum using the last element, and this is the max element not using the right element. And then now I have these things, and then here, so then now for each chunk, let me write it there. For each chunk, we calculate the 4 possible answers, right? And this we just, use left, and this is skip left variations, right? Yeah, and this is why you have a +1, and this doesn't have a +1, and here, right? And then now, now for each query, we update, and then after this update, we have to recalculate this chunk, which is why I have this here, and the chunk is just indexing based on the position, on the size of each chunk, and yeah, we recalculate it. And then after we recalculate it, we just do a dynamic programming, again, to combine them, right? The first index is not using the last element, and this is using the last element. And this is just standard dynamic programming using that as part of these chunks. I'm not going to go over this part just because, well, okay, fine. We'll go over it. So this is basically saying we're not using the right plus this index, which is 0, 1, 2, which means it uses the left, right? Because if it uses the left, then it's okay because we're not using the right, and so forth. And you can kind of reason out all these indexes for the other ones. It is very error prone and mistake, but yeah, but this is the space optimized dynamic programming. So we just keep on going over all the P parts, and then at the end you take either the one that uses the last element or doesn't, and then you mod it, return mod, and that's it. And oh yeah, and you sum it, and that's what idea. And so the complexity of this, there's O of Q queries. Each query we calculate a part which is O of L, and then we combine all the parts again. So this is O of P, right? And of course these are both square root of n. So in total this is O of Q times square root of n. Yeah, this is going to be O of L, right? This is just recalculating for a chunk. So whatever that size of the chunk is, it's going to be O of L. And that's pretty much it. That's pretty much the idea for the square root decomposition. And now, let me take a quick breath. Let me show you the code real quick, so you could kind of take a look and study. So this is square root decomposition. Let me write it down so you want to Google it. I think it's also called like Mohs algorithm, but I don't know. I don't know why, so I don't call it that. And this is algorithm. Right, and that's pretty much it. Let me show you the calculation here, and then let me show you the query part. So yeah, so this is and then you can see that I have a lot of debugging code left just from, you know, But yeah, so then now with this in mind, now we can think about segment trees, right? So it turns out, and I didn't know this very well, but segment tree you can think about. So I'm bringing up the drawing again. Okay, keep this in mind for a second. But so it turns out that, you know, now let's say that you do understand this, right? So now you can. So the thing with segment tree is that now for each so you have an array. Oops. An array or a tree, because it's segment tree, at the last element by element, right? Right. And then the idea here, and this is just a visualization, we'll go over the code. The idea here is that for each node, the bottom nodes, all you have to do is just, and at the bottom of the tree, each node will contain one element, right? So then now you just calculate for this, for each one, we calculate the 1, 2, 3, 4s, which is, this one. No, I'm just going to do it this way. Maybe squeeze it in. Right? So you have to calculate these 4 answers for each node. And then what happens? What happens is that you combine in the segment tree kind of way, you combine these 4 possibilities as well. And because there is a way to combine these such that now the combined node has the same four things, right? And that's basically the idea with segment tree, is that each of these nodes, each of these tree nodes have the same 4 items, and you keep on recursively combining it that way. And when you do, and if you were given a static thing, this still works, of course. You just kind of combine them like very incrementally. But now the tricky part, and the part that requires a segment tree, is that if you do an update, let's say you update this node, if you update this node, when you do a query later, or even when you do an update, I guess, when you do an update, you find this node, and then when you recurse back up, it combines the answer, combine the answer, and you get your answer at the root node. And that's basically the idea about seg tree. Hopefully this makes sense, because I don't know if it does, but or rather, it feels so easy once you understand the components that I talk about in square root decomposition, right? That like I said, I was able to implement this in like 5 minutes or something. But it was a long 5 minutes of understanding all the other stuff that we talked about, right? And yeah, basically this is a tree node. This is my segment tree implementation I got from ChatGPT. The only difference is how you combine them, and so I have a combined function right? So I do sub values is equal to 4, which has these 4 values that we talked about, right? And we have the combine function, which takes the values of left, the right, and then it just does this thing. And all this is just what we talked about, all the possible combinations. If you watch the live portion of this, you'll see me doing it one by one. And I made a mistake in a couple places, to be honest. So way easy to make mistakes, but you know, that's how I kind of, so I did this manually. Yeah. And you can see that on both the build, we just do a combine. We do an update, and yeah, after you update it for one node, you do a combine. And for query, you also do a combine on the left and the right, but I don't even know if this is necessary, because we only do query on the entire tree anyway. So you could have taken the root node and it would have been fine, I think, to be honest. I think this doesn't ever even call this combine. I think it just does. But nonetheless, yeah. So the combine is just this thing, which is, you know, very, I wouldn't say standard segment tree stuff, but again, I didn't talk about it that much about what segment tree was, but you have to know what segment tree is for this thing. So I'm not going to go over here. Otherwise, it's just going to be another 2 hours or even longer. And I don't even know segment trees well enough to teach everyone everything. I think the only other thing that I had a minor issue with and had to think about is the one node case, right? And the one node case, I reasoned that like this is build and the other one is the same anyway, and update, right? And the idea here with these two is that because we want to update a value to a value, the idea is just simply that if you look at our structure of the 4 things, I just think about it as having a segment of one element, then what are the possible answers for these 4 things? Well, this is going to be just the element, or maybe, I guess technically this should be the element or 0, but I think in a lucky way it's fine because I have all the other zeros. Because you will just take no elements. I think that's why. But so I'm a little bit imprecise here actually. Now that I kind of think about it, so this should be max of value and 0 if you set it to negative. But I think, but I think because of all the other zeros, and you would always choose to max out all these 4. It doesn't matter. But it's still a little bit awkward. Nonetheless. Yeah, and once you do that, everything will combine automatically using this combination, and you should be fine. And that's pretty much it. If you look at the rest of, I mean, I'm not going to go over all my segment tree code. Like I said, I got it mostly off ChatGPT in the sense that if you look at the last portion of how I did this, you'll see how I modify it. But really, I just changed, because there was something like self.sum, and then because that version you just sum up numbers, right, instead of combine, and I rewrote this to use combine to do this thing for combining 4 values according to these things and the rules that we have here, and the base case is only the other thing. So I'm not going to go over this code that much, but I will show it to you because why not? Like I said, I got most of this from ChatGPT, so I'm going to scroll slowly. You could pause as you need. And then the rest is just pretty straightforward, right? It's just we set a segment tree with the input as nums. Again, because what we're doing now, what I did or thought about doing it is just having the leaf nodes of the nodes with one element. We just set it to the initial values, and it'll combine automatically to give you the answer. And then for each query, we update the query at that position, and this update will automatically do all the will find the places to combine everything. So so that should be good. And then after that, we do a query from 0. Basically, we query the biggest thing after combining everything, and max because it returns the 4 values. So we choose the max of that. We mod it, and that's it. As you can see, this is relatively straightforward. After the segment tree is done, but the hard part, of course, is all the understanding. So yeah, so what's the complexity here? Segment tree construction is n. I think it's n log n. Actually, I don't know. Hmm. Well, yeah, no, this one is gonna be n log n, I think. Uh, yeah, and then this, in any case, this is q, so this is going q log n, and this is also log n, so this entire thing is going to be q log n log n, and that's all I have for this one. Let me know what you think. This is ridiculous. I don't think I can solve this problem, because, or in the sense that, like during the contest, I knew, or I didn't know, but I was thinking through dynamic. I was thinking with segment trees, and I still couldn't figure out this one. It was only using it this way, and I was like, how do I combine them? And once I figured out how to combine them, I was able to come up with the square root decomposition, but it wasn't fast enough. Otherwise, I would have kept it. But I still thought it was good practice to use it this way, and most of this code is just here. And this is slightly different than this here, because of this is a dynamic programming, so it only has, I only care about not using right and using right, but here is a little bit different because you're combining things from left and right, right? So you need both sides. But yeah, that's all I have for this one. Let me know what you think. Like I said, I think a lot of this has 1,000 accepts, but I think a lot of them will, if Leetcode wants to fail them, will fail them. I don't know if they will. I don't care. I lost so much rating. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve it live next. Remember to fast forward. There's a lot of it, but if you really want to think through how, because I do this question a lot where people think I make everything look easy and just know the answer, and I cheat, not cheat, but like I look up the answers a lot or very quickly. But no, I mean, you saw how I grinded. If you want to watch it, you could see how I grind. Maybe it's not that interesting, but that's all I have. Thanks for watching, and you can watch me grind it out now. All right, YOLO. If it still times out, I feel like, let me YOLO back to Python version, because I feel like I'm not confident about this one at all. But apparently I should have done it in C++. Huh. I mean, that is just weird. I don't know. Okay. I just got wasted a lot of time without knowing. 36 submissions, okay. Okay, 38. Mod. Let's do the mod first. I just saw the mod real quick. Position X. Enter the code I, which is the max. What? We set. Okay, so we have nums. We set nums to position to equal to x sub I. Okay. Then we calculate the answer to query I, which is the maximum sum of subsequence where no adjacent elements are selected. So let's change this. And it's a set. We need 12. Okay. Non-adjacent elements. People got, well, 36 people got it, so good for them. I think it's just kind of crappy that Q3. Yeah, a lot of people didn't solve Q3, I guess, because I think they don't believe that the crappy answer is right. And I didn't believe it either, to be honest. Unless there's another solution. But okay. And it's big, so obviously we can't just do a .dp on each one. And x sub I could be any number. This is not an easy problem. I don't know how 36 people ran it, to be honest. 50 now. But I am like 10 minutes behind, so. So there are only two cases, right? Whether this makes it, the query makes the number bigger or smaller. How does that affect things? Man, I really have no idea how to even think about this one, to be honest. 50 people did though. Okay, we never want to take a negative number. Okay, fine. Right? That's fine. But we can't just take all the positive numbers either. How does that, is there like a standard thing that I'm missing? How does, okay, so let's say we have a maximum sequence. I mean, this is just going to be 12, and then this doesn't change the answer, but this does. I mean, the other way to think about it is for each every number. Okay, we get all the queries at the same time. So can we abuse that? Like for each number, how many times is it the thing? There's so many queries though. Can I DP? Also, like if you have, like you go with 10 0 and then 0 10 in 2 moves. What does that mean? Right. You have something like 10 10 10 10. You remove one of them, but it doesn't change the answer. So then I would just go to the alternating one. People are getting at a very quick pace, though. I don't even have like an idea to play around with. What does adjacent mean? Like, is there something that I could think about with non-adjacents? I didn't even get Q3 fast enough to DPS of n, but how can we use the queries in a smarter way? And it changes the answer possibly even if you don't change the answer well. Right? Like if you have just two elements, like 10 and 20, and then you change one of the 10 to like 100, then the answer is 100. Am I misreading? What properties am I missing? I could just think of the DP. Well, the query doesn't change. The only thing that I have an idea about is that the query doesn't change like the prefix or the suffix. So then it maybe it's just some idea around that. Like I think I get it. Maybe. Because then once you change that, then all the prefix going that way changes. So how do you not recalculate everything? I mean, I guess I see how to do it. But it doesn't seem easy at all. I mean, people did it in like 8 minutes. So I feel like the way I'm thinking with like some crazy segment tree and stuff like this doesn't seem like the way to do it. I have too much segment tree and query stuff in my mind. What the? What the? That's weird. Okay, let's write out the DP for one case, right? So you either take this number or you don't. What are you doing, Larry? I know this goes out of bounds, which is awkward. I think this is right? Oh, no. And now we have 359, so it should. Okay, this is not quite right. Oh, then I'm not adding X. Yeah, well. My base cases are pretty bad. Okay. Right. And then now you're saying, how do I do this? Let me double check my Q3 actually, since I don't know if I'm going to solve this at all. Even if you did it in like 8 minutes, 6 minutes. That's actually pretty fast, so I don't know, that's kind of weird. But doesn't matter if I can't get this one though. So now changing X, what does this mean? Changing X means that changing 5 to 0 means that, oh, to -2 even, just converts this to, we don't know that we took or not take, right? I mean, I guess in this case we do, but we convert this to whatever, and does that change anything? Then this would in theory have to be evaluate, though it doesn't. Well, let's say this turns into 1,000,000, right? Then this would be 1,000,000. or even this turns to 1,000,000, then this affects this stuff. Okay, so it only affects this number and then this number, right? But then everything after that cascades. This number changes, but then that, like if this changes to 1,000,000, then what happens? This changes by a number, and then like suffix changes everything. Start to, like, even if that's the case, how do people get it so quick? That's not an easy thing. Maybe I'm wrong. All right, well, it's the only thing I got, I guess. Let me try something more first. Okay, I mean, this is kind of what we expected, which is good. I mean, well, but then now, what can we do about this? We'll see some evolution. Okay, so you have this. Let's do a generic self. Okay. And then now once we set this to -2, this affects this. This one doesn't have enough negative numbers, I think. But when we set this to 0, then this. Now everything is subtracted by 3. Because that was part of the critical path, right? And then we set 8 is -5. I guess 8 is a little bit too low. And now let's say we set 0 to 10. Is it just everything goes up by 10? So we get something bigger, then this entire way goes more. If we choose something to go smaller, that's not, but this one is the hard one though. Because it only propagates on the even things. or we choose like this goes up by 10, but this goes up by 1, this goes up by 10, this goes up by 8, 10, 8, 10, 10. So it's not even super clear to me if we're going to do a range add, how that would work. And you have to reevaluate the paths and all these things. Man, I don't know how people do it so quickly. And is it a standard problem? All these people got it so quickly. Like 100, like a good amount of people are solving this. It's not me though. Change like I mean this updates and then this updates, but it's only even changed by 1. How do you even figure that out? I mean, okay, we changed this, we have to calculate this, that's fine. We have to calculate this, that's fine too, but then we have to calculate everything is not fine. Especially since this is an 8. 8 change instead of a 10 change, which is actually very awkward. I might get why, but I don't know how to resolve it. I was hoping that all this would be like a easy fix, so I don't even know how to do it. But yeah, like for the example, just not changing, and I don't know what the 3 used to be, but no, 12, so we just get rid of the 12. So yeah, I mean a lot of these things There's gonna be a hungry Larry. What am I missing? Like I get that maybe there's some parts that are localized. But this only changed the final answer by 3. And can you do it without recalculating everything? Because here, pretty much everything afterwards changed past 3. There's like so much branches and stuff. Can I do it like counting? I mean, you can't do anything greedy because that's why we have DP. Changing this affects this, which affects this. But how do I? And you have like tie breaks and stuff like this. I don't know that this is the way to do it. I'm missing like one observation. Can I do it backwards? Well, let's say I have this. I mean, backwards is just the same problem though. Okay, we have type 4, and now we unupdate 3. We don't even know what 3 is. Well, the third element is before this, but we don't go. Can I do it backwards? What does that even mean? I mean, a lot of people are getting it, so this is maybe my worst contest in a while, but I don't know. You have to do it once, maybe. We know that we don't have to update the prefix, but the suffix we do. Right? Is it segment tree? Alright, let's just. How do I do it with a segment tree? Okay. Do you have a segment tree? have to build this. Need a build function. Maybe. I mean, I feel like this is a segment tree problem, but I don't know how to do it. Not gonna lie. But apparently 484 people do. I mean, I could also use square root decomposition or whatever, but maybe. I'm going to update for square root number of them. Okay. I mean, I don't think I'm going to have time to finish it, but it's something new, so let's try it. Yeah. Yeah, okay. Maybe a little bit slow, but we'll see. Okay. How do people do it? I've never done it before, so but I think that makes sense. Okay, so then now we want to calculate 4 possible answers, right? Imports. Never mind, never implemented this before, at least not in Python, so it's been a while. "25 minutes is not going to be cut, but I'm going to try my best. If I need to take more time, I need to take more time. Okay, so then now we want to calculate this. For now, I'll do some numbers equal to. This is not a what? Okay. DP is wrong. And now we have, okay, so 1,000 things. So now each square root is going to have 632 of them. Okay, so that looks right. Okay, and then now we want to return 2 things, right? we want to return so now this uses one thing, right? Okay, so now this is use left right. Let's go to this. So no left, no right, and then neither. Oh no, well. Okay, right. So this gives me 4 arrays, and then answer sub I is equal to okay, right. Now for px in queries. So we'll calculate 3 blocks. I don't know how many. I don't know how so many people got Q4 of it. Okay. So then now, just for science, we want to say for I in range of so this chops down, so we want to do this +1 maybe. Oh, oops. Okay, we want to see that this works, which is that. Now best sub. So we have left, let me see. So we have left, right, and then we have no left, right, we have no right, left, and then no left, no right. So okay, so then now LR can go to LR. So LR just wants no left. Okay, so either one is fine. Also wants no left. Either one is fine. And then no right can use left or no left. Okay, okay, that makes sense. Okay, so best of 0. So we also is to answer sub-0, and then now best sub-0 is equal to max of best sub-0. So then it would be answer sub I of 2 and okay, so it wants the max of these two plus best sub-0 best of 1 as well. To 3 will have max of all 4 numbers because it doesn't really matter. Oh, it's not a result. Well, I mean, okay, fine. Intent list. This is all. Oh. Best is a list, right? What am I doing? Best is a list of lists. Why? Enter Sub-Zero. What? I don't have time for this. Yeah, but okay. So enter Sub-Zero is. Oh, this is an array. Okay, that makes sense. But we actually want just the last element. Give us the answer. We don't need everything else. Okay, well, except for when it has no answer, I suppose. Yeah, whatever. Int object none. Okay, fine. Okay. Okay, we don't need. Well, I mean, it'll be nice, but we'll just see if it works with the input so far, and the answer is no. Oh, that's because we haven't we don't do the update. Okay, so it's gonna be 12. I mean, that seems okay in theory. We have to actually do the real though, which is we have to update it, right? So here we want to update num sub p is equal to x, right? And then now we have to x, and then we recalc n sub I. Oh, we have to n sub I. I is equal to p divided by m. This is true. It's not true that each pieces have this though. The m pieces. No, this is the size of each one. and then pieces is actually the length of ends. Alright, I mean, this is probably not right, but I got nothing else to go on, so I'm going to YOLO submit. I probably should put some mods in here, but I think it doesn't matter too much. Let me just at least do this though, because I don't think the numbers gets too big, but I could be wrong, to be honest. Let's give a YOLO submit. If it times out, I mean, I'm okay with that, because I feel like square root decomposition is a pretty good solution, even if it times out. I mean, it just I don't it's hard to judge the constants, but okay. Well, wrong answer is not as good though. Okay. Why? I don't know why that took so long then. Did they tell you what problem? No? Okay, fine. So this is, the answer is going to be, so you answer 6, I expected 9. Why? Because the answer is 3. Is that 3? No. 0, 1, 2, 3, 4. So no, this should be. Why is that? What is? Okay, what is it before? Oh, not. The answer is, why is this so? I am calculating M wrong. 1, 2. I have 10 minutes. I don't know if I'm gonna get it in 10 minutes, but so we have 6 and 4 is the M. We don't have M pieces. We want each part to have M things, right? So then now, so pieces is equal to n divided by m, and then now we do the p. Maybe that's slightly cleaner, but I don't know if that fixes it though. And it doesn't help that the thing is whatever, but this is a very bad time for things to not get submitted and pending, but I mean, it's okay. If I don't submit it, I don't submit it, but I feel like I'm almost right. It took me a long time to get to this, but well, I mean, I feel like if the server doesn't have issues, I still have a chance, because I think I just have to clean up some stuff. But okay. Like but server's just not doing well. can debug, can debug. Sorry friends, I have to do this offline. I mean, I can. I hate this. I lost my wrong answer, didn't I? I think it was like... I mean, my issue is kind of with whatever anyway, but I don't have all the inputs on my computer. This is silly. Why is M so big? I don't have the thing to do it locally because I don't have all the random like list stuff. Typing that list. Unknown error. Do the square root. I feel like I mess up on this easy part of square root. I don't know. Can one code? YOLO submit. I mean, it may be. I can't test anything, so I'm just YOLO submitting because this is the same wrong answer I got before, and I'm not surprised because I can't test it. Right? And now, I mean, maybe now I can, but I didn't have a copy of this. My answer is 6. It should be 9. I mean that's 1, 2, 3, 4. I got 2 wrong answers on the same thing anyway. I mean, I don't even know. It doesn't really matter. I can't. This is a very frustrating experience. Why is that? Why is that? Why is that? Why am I doing it here? Okay, so why? Three, 4, 4, 2. Okay, I mean. Each piece have M object, right? Oh no, off by 1. I don't know. It's not inclusive. Okay, well, it's too late on the submit anyway. I think I just missed it, but I mean, it was a YOLO submit, but let's see if we can, now. I mean, I'm not surprised I have some silly mistakes, but that's like if I have 10 minutes, I could fix it, right? So I think that's just stupid, but that, like, I don't have the time for it. Let's see. Let's look at this one real quick. I mean, this probably would have timed out anyway because I have so many print statements. But I think the idea is right. This was an actual silly mistake by me, but that's fine. All right, let's see if we remove some queries, would we still be right? Let's actually make a copy of this. I mean, I don't know what to say. Like, I feel like I had a good chance of doing it, but yeah, I just couldn't get it done because, because I wasn't given a chance. Okay, so you have 8. So then why is expected answer 7? Let's see. So you have this. You said 0, 1, 2, 3. So you set this to a 1. Then, but you just ignore it. It's 4 and 3, so it's 7. Why do I think? Why do I think? What is the answer before the calculation, before the change? So you have 4 and what do I have my notations? Left, right. Okay, so why is this 8 after you change it to a 1? Because each piece is 4. So then, okay, so then this makes sense. Because, well, so this is a 1. Did I do this one wrong? 2, 3 is, oh, I mixed this up. This is actually 1, 3. Okay. I mean, these are things that are easy to debug if I had 10 minutes, which I did not. But, and still now it's a little bit having issues. Okay, and the other one fixes too. So I just had silly mistakes, but it's just very frustrating because I was very close to getting it. I'm 3 minutes over the budget now. Maybe I'll still time out anyway, so maybe it's moot. I actually don't know what the right way to solve this is. I thought maybe it's something segment tree, but I haven't thought about this idea in a while. Maybe I could have been a little bit earlier in coming up with it. I just didn't do the math, but I mean, if it times out, maybe it doesn't matter. But at least I was right. It is very the timeout case is actually very close. So okay, still wrong answer. But let's take a look. Let's take a look at the first case first. Okay, so it's right for this one. All right, what about 8, 7? I mean, it may be that I just have a wrong thing somewhere. This should also be 0, but I think it should be good though. Okay, so adding this changed the answer. Why? So this is the array. So okay, let's actually just remove the first. No, you need the first query, so we can just remove it and then we replace it with 4 here, and I think that will give us the correct wrong answer to debug. What? How is this right? Did I screw something up? Maybe the update is not quite right the way that I do it. 3, 4 is good, right? And then now we add a 8, 7. Should this be P? I don't think so. Did that change anything? Yeah, I don't think so. But how? All right, let's take a look again. This is -1. What are my inputs? So this is the before, this is the before. $24, so this expects, how did I get even 40? How? 8, 7, 0, 1, 2, 3, 4, 5, 6, 7. So just adding it by 5 would not give it that much anyway. How did this happen? 10, and then you have the first 4 elements. That doesn't even change the first 4 elements. Did I do the math wrong here still? First 4 elements. Do I double count an element? Is that possible? How does this even give me 24? Am I looking at the same input? We said 3 to 4. All right, let's print the other thing. Okay, so this is the before picture. We set a change and that bricked things. Oh, no. Did I mess something up? This is definitely wrong. I don't know why this changed so drastically. P is... Yeah, I mean, we change the first block. What? I'm just doing something funky, but okay. The first, no, we changed it and it's fine. So 0, 1, 2, and then we, okay, so we print this and then we update these, right? That looks good. So then what happened? Did I do something silly with answer? Oh, oh, this is dumb. Larry, you are dumb. That is, how did that not come up before? But okay, fine. Okay, fine. Okay, well, I mean, I'm still getting wrong answers. Maybe it's the negative numbers. At least I fixed that one. That is a silly mistake, but okay, fine. So many. So that's right for one case. Okay, so this is already wrong, which is good. And can we do the thing where we skip 8 and 2? 1, 2, 3, 4, 5, 6, 7, 8. Set it to 2. Does this still give me the wrong answer? Yep. Okay, good. Why is this wrong? Dun, dun, dun. We have 9, so it's 4, 4, and 1. How do I store my things again? I forget. So yeah, so it should be the used left should have stuff. Okay, so I guess that's accurate. Let me also just print the freaking nums here, so I could have some instead of keep on scrolling back and forth. Alright, I mean, I guess maybe I wouldn't have solved this, but... And someone told me on the Leetcode that apparently the n-square solution passes, so that's why a lot of people got it. I don't know. And maybe I should have done it. I mean, Q3 feels the same way about it. That's why, I mean, I understand why so many people got it then. Because what I'm doing is not easy, it turns out. All right, let's see. So this is 5. My expected answer should be 1. Yep. Let's see. So the blocks are 4. So this one will give me a 1. Okay. This one gives me a 2 for the left and the no. Yeah. Okay, that makes sense. Left, no right. Or no left, right. So okay. So that makes sense. So okay. So you have a 2. And then we use the last 2. I guess like 1, 2, 2 is probably what they were thinking, or my code is thinking, but why is that not right? 1, oh, because, yeah, I mean, obviously, this is not right, but what am I doing incorrectly that's making this not right? What did I put as best? 3, 3, 5, 5. 5, 5 is no left, no right. Am I doing it wrong? No right, you could take any of the other ones. I think that's true. Okay, so then now, alright, we can just, I'm struggling today. Just give me all the updates. Okay, so you have, okay, after the first thing, it's gonna be 3, 3. Which is probably right because we don't care about it. So it should be 3 after this. But then now you don't want, or wait, that's not true, right? Why is, oh, I think I'm updating it wrong. So this, oh yeah, okay. So I'm just being a little bit dumb on this one because 0 is using the right, so we can take all the other ones. 1 is using the right, but this actually has no right, so we cannot take an answer that uses the right. So this is actually 2 and answer is 3. Okay. Okay. Let's run it real quick. Okay. Silly mistake. Or I mean, definitely at the end I had some time pressure. Though I guess that doesn't explain here, but it's going to be moot because it's going to time limit it anyway. But at least I have something, I suppose. Apparently n squared passes. That's why so many people got it. It's not an easy problem. There's supposed to be a segment tree problem. I don't know. And apparently I still have wrong answers. Is this right? I mean, no, this is definitely not right because we have to add 0 in somewhere. Because it doesn't make sense, this one. Okay, let me actually think, Larry, think. All right, so you can use left, right. So you, what does that mean? So that means that you only take the answer from not left and not right. So that's 1, 3. Okay. I think I'm just being too fast. This doesn't even make sense. There shouldn't be this symmetry. So use no left. But a right. So that means that we can use left. So yeah, so this, I guess, no, Larry. Use right. So then now this updates. Oh, I guess this makes sense because I can use this or this because we can skip it and not use it, but we can just use it. Okay, fine. But best 1, I'm not doing this cases analysis right. I just kind of rushed this part. Okay, but then this, actually it's the same idea though, right? As long as it doesn't have a left. So okay, so maybe this time this thing is right. Okay, best 2 is going to use left, no right. There's no right, so you can use any of these things. But this state requires a no right, so it's only 2 and 3. Right? And then here, there's no left, so you can use. I think I'm writing this wrong. I think that's why I think this part is the confusing part. I think I'm writing this wrong. This doesn't make sense. The symmetry doesn't make sense. That's what I get for being shortcut. But all right, let's rethink this. Right. So okay. So this, as long as, so this is the previous. Okay. Okay, so let's just say okay, so then use left and right is going to be max of, I think this part is still right, because as long as you don't match it with these things, it should be okay. Use, and then I kind of just like based symmetry on it, and then I was wrong. Because this is looser, so you could do use itself and also this part, right? Yeah, so I think this is also right, but maybe I'm wrong, I don't know. Okay, and then now this part, is, you should be able to use anything, but it's the 2 and the 3, because that's how you update not using the right. But I think that's where the answer is wrong, is because it is saying, so then now use left is right. Is that I am struggling with this a little bit. That means that we can use all 4 really, but they all have different scenarios. Yeah, I'm returning a smaller number than it should. So I think it's this, and also no, it is no way. Okay. So this solution is that it doesn't, and then best of 2. So what kind of combination? So then this is the solution in which, why do I have 4 things? I'm so confused. Shouldn't there be 2 things? Like whether we use the right or not? Yeah, I think maybe I'm just confusing things, because I think like the way I'm doing this is very weird. So okay, so then now this is going to be, let's see, right? Just or maybe not. It is whether we use the right or not. I think that's the only thing that matters. So then this is max of, let's just keep it to, okay, so I mean I wouldn't have gotten it, I think, just by time, but I think the idea is still, I don't know if it's fast enough, but the idea is right, maybe. Okay, and then now, okay, right, and then So next of 0, okay, so 0, no, not right, not using right, 1 is equal to using right. So then now this is going to be equal to the previous using right, or not using right. This is not using the right, so that means that it can use anything. But the answer that we care about is keeping the not using right. So it is going to be the third element. And then it's max of this and this. Right? This is using right plus no left. No right. So then this is I3. And then 2 is use left, no right. And now we want to get a left and a right. So then we have answer I0. 1 just by symmetry maybe, I don't know. And then best is equal to next. Index out range, what? Oh, it's not best of it's what am I doing? I'm still confused, but okay, so best of, okay, what is this? This is use left, so this means not using right, so this is 0 and this is 1. Okay, I kind of confused myself the notations, but looks okay here. Yeah. Do I have any print statements? No? Okay. YOLO submit after like 5 wrong answers and half an hour later. I mean, this may time out. It's fine if it does. I feel like we're probably on the bounds of it. Though it is very crappy that this times out, but not the brute force DP that someone told me about. Is it just this particular case, or? Okay, this time limit exceed. Why is that? Let me hopefully print out my MNP. Do I not do my square root right? Which is possible. I think this should just be square root, not n over square root. Maybe that's a little bit weird, honestly. No, just time limit exceeds without any I mean, I think we made a good attempt. I am going to review other pure solution. I'm told that is segment tree. I did kind of know that it was segment tree, but I mean, this is pretty good. But if time limit exceeds, can I be a little bit smarter? Not really, I suppose. N is, this is basically max N. But why is that? Why does that time limit exceed? 50,000 times 223 is 11 million. I guess so. I think what I was going to do, to be honest, is that I thought this might time limit exceed, and then if I had fixed it and it does time limit exceed, I was going to convert to Java. Convert to Python, please. Oh, I said convert to Python, please. I am dumb. Convert to C++, please. I have to be careful here with the ints and the longs. Because because I think here, oh, maybe that's why. Does this make it faster? I don't know. Let's actually make sure I at least do these things. Still time limit exceeds, but I don't know by how much though. Would be nice if I can convert to C++, please. Use long everywhere. Still time limit. That's sad, honestly. Let's see if this is good enough. Or can we even run it? Compiler error. Okay. How do I rewrite this? I did write that. That part was a little bit lazy. Maybe that's why time limits. Let me rewrite this actually. Let me rewrite it to Python part. No, I mean I feel like this is pretty fast to be honest. Equals in right, and then I mean, I think now we're at the stage that like we have a correct solution. It's just a little bit too slow. Yeah. How? Oh. Huh? Oh, it's this part. Oh, maybe I have some weird off by ones here. Yeah, okay, there you go. Convert to C++ again. Well, that's not a good answer. And still time limit exceeded. Huh. I don't even need to use all of this space. I think the space is a little bit weird, but it's fine. Oh my. Oh, it's off by 1. Still time limits exceeded though, but we'll see if this actually is fast enough with C++. Alright, looks okay. I mean, I have some printing out statements, but it's fine. Where is my printing out statements? Oh, it's just the top, which is here. Still time limited. That's actually very sad because I feel like this would be a very cool solution. Yeah, I don't know that I can optimize that much more, to be honest. I mean, we're close, but not quite. I mean, that is the issue with not knowing how many test cases, because it's just never know. Which is actually very sad because I feel like this would have been a very fun solution. And I'm trying to think where I can optimize this a little bit, but I don't think so. I mean, maybe I could optimize this part. How fast is this without it? 1.6 seconds. Let's say if I don't do this work, like if we could convert this a little bit more better. If there's a way for us to optimize this part, because we only changed 3 cells, but then it does cascade. I'm trying to think whether I want to optimize it or even think about it. I mean, I think this is a good try. It is what it is, though. I don't know. I'm not happy that there are 2 sick tree palms, but it is what it is. trying to think, but I mean, so yeah, so people on my Discord gave me this link, which is to say, yeah, so apparently the solution is available and it's using this seg tree. And the idea is very similar, but it is what it is. I mean, it is very similar to what I do with the... it's too big. Let's see. Still too big to share. I'm just basically on Discord. Hang on. Just trying to get this looked at, maybe. Wow, I don't think I've ever been 1,000 before, huh? I guess a lot of people sub-queue. I guess so. Well, a lot of people sub-queue for because they use Java and they did the dumb thing that I didn't do. Sad Larry. Well, I don't know how to even like how many people if Q4 fails, how many people have gotten it? I mean 16 minutes. And the thing is that I was actually also slow on this because I think this should time out too. I don't know why that, you know. What a crappy gun. So I wasn't even that fast on Q3 as a result. I don't know. I don't think I've ever done this poorly on a contest before, but I think Leetcode really screwed things over this time, especially with, you know, people literally doing the brute force thing, process and recompute. Yeah, I mean, maybe they could have recomputed, but for like a subsection, but that still should not have been fast enough. I mean, this is the sig tree one. I actually know the sig tree answer because, well, I mean, it's here, but it's very similar to my answer, to be honest. So it's actually kind of interesting in that way. So I could maybe come up with it because I already have some part of this, but sorry, I'm just taking a little bit mental break because that was very tiring. But and apparently this is a sort of a textbook problem. Apparently a lot of people know this one. So this is a... I mean, I thought about doing it this way, but I didn't think I knew how to do it. But now that I explored the square root decomposition one, I think I know how to do it. Kind of like this, I guess. All right, let's do it. My watch is telling me to stand up, but it's okay. All right, let's actually do it with sig tree. I mean, I guess now it makes sense because I didn't know why, or I didn't know why or how everyone got it so quickly because I don't think it was a easy problem at all. And even the way that I did it, I was just sloppy, but that's besides the point. I'm trying to find my chat GP so I could get a segment tree. And I get a generic Python segment tree node code. Okay. I don't know if this is good enough. Let's take a look. Is the syntax weird? I guess so. Alright. What is going on here? I don't know this version of the segment tree. Let me just... Now you get a version inside a class. Okay, I mean, I guess this is a good thing to learn. Okay, so no. This is such a weird looking one, but I guess this is the sparse one, but okay. n-1, okay. How did I set this up? I don't even know. It's been a while. But okay, so we set it up as 4 values, right? Which is the same as here, say. Initialize, okay. So we initialize with just values of 0. So this is going to be half a value, but everything else will be 0, right? So okay, so then build segment tree. If they're the same, then now we want to say the values is going to be, like I said, this 0, 0, 0, and then now we have left and right, and then now the sum. Now we have to do this, implement this. Okay, and okay, so that's the build. Maybe I have to do like an update thing. Like root.values is equal to self.combine root.left root.right, and then I can just implement this once, right? I replace that here, and then everything else should be more or less the same, right? Okay, so then we just have to implement the combine, and the combine is same as what we had. So left, right, right. So then this is not confusing at all, but okay, so v is equal to right, or maybe just return. Okay, so then now the first value is one left and the right, so it's going to be left of 0 plus right of 1, or left of 3 or 2 plus right of 0, right? Yeah. So no left. Okay, so that's left, using left and right, and then this one is going to be used not left not right, so then it is going to be left of 1 plus oh, plus itself. That's why I was confused. Okay, and then or left of 3 plus left right, so that's 0. Okay, and then now this is left of 0 plus right of 2, or left of 2 plus right of 1. I hope I'm right on all these because debugging is going to be a mess. Okay, so no left, no right, so it's going to be 1 plus right of 3, or left of 3 plus right of 2, right? Yeah, okay. And then we have to update this. Okay. Okay. All right. So no more pretty whatever. But I mean, I learned some stuff about this, so I don't think I feel that bad about it. Losing rating aside, I think this is my worst contest in a while, but that's fine. I don't care. Let's see. Seg tree is equal to segment. What do I call it? Segment tree. Of nums, right? Yeah, I think we could just do the nums. I don't even have to do the DP part on the value, right? And then now we want to say st dot update. What a silly name. P and X, and then there should be just st.query segment tree 0 and -1 maybe. This plus is not right. It should be combined. Yeah, maybe. We'll run it real quick. Segment tree. This is a node. Oh, okay. Well. Yeah. Okay. Well, if it works, maybe I'll clean it up. This is very messy, but I just wanted to. Okay. Oh yeah, I knew that this returned a list actually. I was just a little bit lazy. Okay. I mean, that worked very quickly, so let's give it a minute. I mean, this is the same long answer I've gotten before, which is kind of funny. But 12 is because... I don't know, actually. I mean... So this is going to be 6, right? 3, 3, and then convert 0, 1, 2, 3, 4 to 0. So then this is just 3 and 1. So then why is that 9? 3, 3 is 6. Oh, 6 and... Okay, yeah. It's 9. Wait, now. If you convert 0, 1, 2, 3, 4, 0, then now you have a 3 and a 1, so 4, right? So 6 plus 4. Oh, no, you don't do the 6 yet. Okay, so it's going to be 3 plus... yeah. Wait, what? So this is 6. And then 3 is 9. Okay, fine. Because 0, 1, 2, 3, 4. Convert this to 0. How do you still get 6? Am I confusing? I mean, I am. But 0. Oh, that's the 4th element. This is the 4th. Okay, I'm just being dumb. So this is 0. You have 6. You convert this to 0. Now you have 3. Okay. How did this happen? That means I'm doing some maths wrong. Let's take a look at this for symmetry. It is so hard. Okay, let's think of this another way. And this is just for both, for one element. So I think this is right, but okay. So left, right, plus no left, no right. So 1 plus 3 is going to be 2. Oh, 0 plus 2 is going to be 2. Okay, that's right. This 1 plus this one is going to be, I guess this one. So this is just not a good exercise. Okay, so 2 plus 0, this is right. So this is good, I think. Left 1 plus right 1, it's going to be same thing. Yep, okay. Left 3 plus right 0 looks good. Yeah, okay. Left sub 0. So I did that. I'm doing something like funky, like updating the position of whatever. I don't know. Like which one is that? This is a bit like this doesn't even make sense. This is this use left no right is just this thing, so I don't know why that would change things necessarily. Okay, let's just finish this. Left 0 plus right 2. Ooh, this is not right. And sometimes that's all it takes. So the second one is going to be left, not right. So it's this plus 3. Okay, so there's some symmetry that you can kind of see. And maybe this is wrong too. Left of 2 plus right of 1. Yeah, this is wrong as well. This should be this. Should be with itself. Wait, what? Okay, so this one, it's going to be this plus itself. Okay, so that is actually more right. Left this one plus right of 2. Okay, that's right as well. Alright, let's try again. Maybe that was it. It was it. Well, at least for this example, I print out too much stuff, so it may output limit exceeded. That's okay. Oh, let's give it a submit. Yeah, I mean, sorry. I think I am also going to be okay, so I think one thing that I can do is actually exploit this a little bit, because this and this has the same prefix, but this right. So then I can maybe return yeah, maybe I could do something like this. Technically this, because the other one is going to be yeah, I think I can maybe do it this way. I mean, it'll be 2 times as fast, but we'll see if that makes enough of a difference. I don't think this works, because I have to probably make an additional adjustment here. Yeah, on this, but it is a good try, maybe. Oh no, I have to do it afterwards. I mean, this is just a lazy attempt. Maybe I can see how that works. Tuple and what? Oh. Unpack non-immutable int object. Oh, because of this 0. I mean, this should be 2 times as fast. And maybe we can... I mean, I don't know if this is going to be fast enough, but I just thought it was worth a try. To kind of revisit it, but... Yeah, I mean, it took 11 seconds. I don't think this will pass, but why not? Why not? Why not? I do wonder if you can... Like, we can also calculate less than this, but... So maybe... Let's say we have this. Does this work? I mean, it probably doesn't in the sense that... Oops. That's not what I meant to do. I mean, because I think it might affect certain things, but I think... I just want to see if it's speed-wise is it fast enough. Like, I think this will give us the wrong answer. Maybe not for this, but let's give it a submit. Because it should affect adjacent ones if you update a P that's like right on the border. But maybe not. I thought it might, but maybe not. Still time limit exceeded. But that's actually kind of crazy, because I thought that this would actually be incorrect, but actually maybe not. Maybe it just gets factored in. Yeah. Oh well. I mean, I really did like the solution, even though it's a little bit too slow for Leetcode. So I don't feel that bad about learning and practicing this. But yeah, I mean, we're only missing by 4 cases, but if it takes 4 seconds for one of them, I don't know. Like, maybe we can, if there's a way, can I be smarter about this? Like, maybe I could speed up another factor of 2, but I don't know. I think this is what I'm going to do though. But I would also say that exploring this solution allowed me to understand this solution. So it wasn't like it was nothing, but yeah. I didn't even use, I mean, yeah, I mean, I think I did basically this. I don't know if I didn't really read it, because I had it for my square root decomposition, which I couldn't get. How long does this take by comparison? 3 seconds. Oh no. Let me actually one last time. With C++, and if it's good, then you know. And this should be twice as fast, but and maybe C++ is a little bit more generous. I don't know if it's true. Say what? Oh, type an int. Wait, where? 73? What? Why is this returning a vector long? That is actually really weird. ChatGPT, what are you doing? What are you doing? Alright, let's give it a quick submit. Hey! Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.